Hi guys, today we're going to start talking about Newton's second law of motion. Newton's second law of motion is actually all about calculating force, mass, and acceleration. So remember, a force is a push or a pull, mass is just a measure of how heavy an object is, and acceleration is the change in motion of an object, like if it speeds up or slows down or comes to stop or starts moving. So that's what acceleration means. So when it comes to the formula, we see that if you looked at the STAAR page, you can see that the formula was F is equal to M times A, or in words, force. So the force used is equal to the mass times the acceleration. So when you calculate, you'll use that formula to calculate one of the variables, either force, mass, or acceleration. This is something you already know a lot about. It's very easy to you if you think about it. It's not hard. Which object is easier to move or accelerate? Would you guess a bowling ball or a ping pong ball? Well, obviously the bowling ball has a greater mass or is much heavier than the ping pong ball. So which one is easier to push or pull, the bowling ball or the ping pong ball? Well, if you said the ping pong ball, you're absolutely right, because the ping pong ball is way lighter, so it's easier to, it has less mass, and it's easier to accelerate or move using a force, a push or a pull. If you look at this image here, you can look at the two images, the one on the left with this big machine, and 5 guys are trying to move it or accelerate it. Obviously it has a large mass, so what do you think? Will the force be greater or less to move this large object? Yeah, obviously it's going to be a large force because all those guys are trying to move it. Now on the right, the image shows like a little settings wheel that somebody is holding. Maybe it's a tire, I don't know what this picture is, but anyway, obviously the mass is not that great. The child is holding it up, so the mass is little, so the push or the pull, in order to move it or change its motion or accelerate it, would obviously be small as well. So let's sum it up. If the mass is large, if the mass, meaning if the object's very heavy, the heavier the object is, the greater the force, the push or pull, you will need to move it or accelerate it. So large masses require large forces. Small masses, the object's small, it's going to require a small force to set it into motion or accelerate. When we do calculations, and this is all about calculating the force required, so that's what Newton's second law is all about. So if we look at the formula, force is equal to mass times acceleration, in order to help you calculate and set up your calculation accurately, you can use a force formula triangle. If you look at the formula triangle, it has a little multiplication sign here on the bottom between the two parts of the triangle, and it has another part of the triangle at top. And along the line in the center, it has a division sign out to the right. So the way you set up your formula triangle is first look at your formula and see if anything's being multiplied. And in this formula, mass times acceleration is being multiplied. So we're going to put our mass in one side of the bottom and our acceleration on the other. Now, obviously, that leaves us with force. Force is the remaining part of our equation, so we need to put force in the remaining portion of the triangle. Oops. There we go. Alright, so we have all our parts or variables of our formula in our formula triangle. Now, this formula triangle is going to help you do several things. First of all, it's going to help you decide when to multiply and when to divide. If you have a number for force and you have a number for mass, you would divide force divided by mass would give you the acceleration. But let's say you have the acceleration and you have force. Well, if you don't have mass, it tells you force divided by, that's why the division sign is over here, by acceleration gives you mass. So in other words, this formula triangle is going to allow you to manipulate the formula to figure out and calculate anything if you need mass or acceleration or force. So let's try it out. So let's say we have a mass of an object, which is 20 grams. And the acceleration of the object is 5 meters per second. It should say squared. So we already know the formula says force is equal to mass times acceleration. So in this instance, we have mass, we have acceleration. Grab your calculator. So 20 times 5 is equal to what? Well, 20 times 5 is equal to 100. And forces are always calculated in newtons. So the unit for force is N, capital N, or newtons. So the force applied here is 20 times 5, which is 100, and the unit is newtons. You can write it one of two ways. You can write it as 100 newtons or 100 capital N, which means the same thing. Let's try another one. Okay, once again, we have the mass and the acceleration, so we're just going to multiply mass times acceleration to get the force. So if the mass of the object is 5 grams and the acceleration of the object is 3 meters per second squared, what is the force applied? Well, mass times acceleration equals the force, so get your calculator. 5 times 3 is equal to, yep, you got it, 15. And obviously force is measured in newtons, so the answer would be 15 newtons, or you could write it 15 N. Here's one where we have the mass of the object, which is 5 grams, and the force was used to move it was 25 newtons. So now we're trying to figure out what is the acceleration. So if you put your finger over the triangle and cover up acceleration, you'll see that force is at the top of the triangle, mass to the bottom left. Force, anything from top to bottom, over here to the right you see is divided. So you're going to have to divide force divided by mass, then you will receive acceleration. So force is 25 newtons. Get your calculator. Divided by the mass of 5 grams, so the acceleration must be, you guessed it, it must be 5 meters per second, because we are looking for acceleration, and acceleration is a timed unit, so we're looking per hour or per second or per minute, something like that. Here we just guessed and said it was 5 meters per second, but the number 5 is absolutely correct. You could also write it as 5 meters / second. Okay, this time we get the acceleration is 3 meters per second. So put that in your triangle by acceleration, 3 meters per second. The force is 15 newtons. So cover up mass, cover up the mass part, and you see that you need to take force and divide it by acceleration. So get your calculators. The force is 15 divided by 3. The mass must be 5 grams, or 5 grams, 5G. Alright, so let's try some density calculations. So first we're going to put our formula into the chart, because density, if you looked at your STAAR chart that I gave you, that's attached to these lessons, density is equal to mass divided by volume. So in our formula we have division, so we need to put mass at the top of the triangle, because between the top and the bottom portions we always divide, and then our volume would go on one side, and then the remaining variable of the equation, which is density, would go in the remaining triangle portion. So, if density is equal to 10 grams and the mass is 20 grams, so mass, we see in our triangle, divided by density. So what is the volume of the object? So obviously we're going to take our 20 and divide it by 10, and we should come up with a unit with 2 milliliters as our volume. Alright, let's try a STAAR warm-up. Joe hit the golf ball with a force of 30 newtons. The opposing force of air resistance on the ball was 2 newtons. What was the net force on the ball? Well, you guys have just been working with net force. So what is it? So it's got 30 going in one direction, 2 newtons of force opposing it or going in the opposite direction. So if you came up with 28 newtons as your answer, absolutely correct. What about if the force on the ball is 30 newtons and the ball accelerates at 5 meters per second squared? Now we need to figure out the mass of the ball in grams. So get your formula triangle. If the force on the ball is 30 newtons, force goes in the top of your triangle. Acceleration goes on the bottom with 5. If the force is on the top and acceleration on the bottom of the triangle, we have to divide. So we're going to divide 30 by 5, and that's going to give us a total of 6 grams, must be the mass of the ball. Next one, what force will cause the ball to come to a stop? Well, what force on earth comes any rolling ball to come to a stop? What's working against the ball rolling on the ground? If you said friction, you're absolutely correct, because friction is the opposing force, or the force working against objects that are rolling on the ground.